6.2.9, solve the system of equations. So again, I will label equation 1, 2, 3, draw my little outline to kind of keep focus. Take two equations, get rid of the same variable. Then take another two equations, get rid of the same variable. Then take equation 4 and 5, get rid of another variable. To get equation 6, solve for one variable, plug it in here, and work your way up. Okay, so let's see. If I take equation 1 and equation 2, I can get rid of x. So, and I don't need to do anything other than straight add them. So let me write them down. 8y 4z equals 24. So that would be 5y minus 5z equals 15. So that's equation 4. Equation 5 is I need to take equation 3, and I can either use 1 and 3 or 2 and 3, and I want to get rid of the same variable. So let's use 2 and 3. Let me erase this. Okay, so I'm going to take equation 2 and 3 and get rid of x. So I got to take equation 2 and multiply it by 2. So I get negative 2x, positive 16y, negative 8z equals 48. Equation 3, we just leave it alone. 2x minus 15y plus 7z equals negative 45. Straight add them. So what is that? Negative 8 plus 7 is negative 1z equals 3. Okay, and that's equation 5. Now if we take 4 and 5, we have to eliminate the same variable. So let's see, 1, 2, 3. And then we have to get down to one equation, one variable. So if I take 4 and 5 and multiply 5 by negative 5 to get rid of the y, so we get negative 5y, positive 5z equals negative 15, and you can see everything cancels, so we get 0 equals 0. Now this is always true, so that says there's dependence in this system, and we're going to have an infinite number of solutions in this case because that's true. So what you do is you take, so basically we can't get to equation 6 to solve because it has an infinite number of solutions, so we're going to go back up here and we're going to solve for one variable in terms of the other. So what do I mean by that? Now before I do that, let me see something real quick. We want to write our terms in terms of z is the way the book has it. So we need to find y equals what in terms of z. So we got to keep that in mind. So we're going to go to z to 4 or 5, and we want to solve it for z. So we got y minus z equals 3. No, we want to solve it for y in terms of z. So we want to get y all by itself. So add z to both sides. Okay. And then you're going to go up here and plug in, you're going to leave z alone, you're going to plug in 3 plus z for y, and then you're going to solve it for x. So if I take equation 1, and I see I have x minus 3y, but y is the 3 plus z, minus z equals negative 9. So see, we got for equation 1, x minus 3y minus z equals negative 9. And then we're going to simplify this. So distribute the negative 3. Combine your like terms. So 4z. We're going to add 9 to both sides. And add 4z to both sides. So x equals, so the 9's cancel, 4z. So our solution set is going to look something like all the points, x is 4 times whatever z is. Z is 3 plus z, y, sorry. So x is whatever 4 times z is, 3 plus z is y, and z is any real number. Any real number. Okay, so that's the way you would write the solution set. And that actually makes up a line. So, let's see here. We have 4z for x. We have 3 plus z for y. And z is any real number.